In part 1 of moving charges and magnetism, we understood introduction and Oersted experiment and magnetic field. Okay, in this part 2 of moving charges and magnetism, we are going to understand principle of superposition of magnetic fields and magnetic force. Okay, so magnetic field obeys superposition principle. What is the principle of superposition of magnetic field, or what is the superposition principle of magnetic field? In first chapter, already we understood, okay, superposition principle of electric field, superposition principle of electric charges. The similar way, we are going to understand principle of superposition of magnetic fields. Okay, so once again, so I'll revise what is the superposition principle of electric field. So instead of B1 bar, B2 bar, B3 bar and Bn bar, what we written, what we written there? So E1 bar, E2 bar, E3 bar, En bar, right? Suppose at this point the resultant electric field intensity, what we written? E bar is equal to E1 bar plus E2 bar plus E3 bar plus and so on plus En bar. Now instead of that electric field here, so magnetic field, nothing but, so in this system there are n number of charges are there. That n number of charges are not in rest, they are in motion, they are moving. Q1 charge is moving with some velocity V1, Q2 charge is moving with velocity V2, Q3 charge is moving with velocity V3, right? Qn charge is moving with velocity Vn. Okay, means charges are in motion. Different charges are producing what? Different magnetic fields. Q1 charge produces B1 magnetic field, Q2 charge produces B2 magnetic field, Q3 charge produces B3 magnetic field, Qn charge produces Bn magnetic field at this point. Now at this point, what is the resultant magnetic field induction? Okay, the resultant magnetic field induction at the point due to this all these charges is what? Vector sum of magnetic field due to the individual charges, right? So what is the principle of superposition of magnetic fields? It states that the resultant magnetic field at a point due to magnetic field of several charges, okay, several sources or charges is equal to the vector sum of the magnetic fields of each individual source at that point. Okay, the resultant magnetic field at the point due to the several source or charges is what? Vector sum of magnetic fields due to the, okay, individual sources at that point. Okay, this is called as principle of superposition of magnetic field. Okay, so if you remember principle of superposition of electric field, instead of electric field, if you write magnetic field over principle of superposition of okay, magnetic field, don't waste your memory, right? Save your memory. So superposition principle of electric field you understood, right? Yeah, okay, what is superposition principle of electric field? Superposition principle of electric field states that the resultant electric field, instead of magnetic field, what is that? Electric field at a point due to, what is that? Okay, instead of magnetic field, electric field of several charges is equal to the vector sum of the magnetic, not magnetic, instead of magnetic what? Electric fields of each individual charges at that point. Simple. Okay, if you remember one definition or one statement, okay, then easily we are write that. So principle of superposition of magnetic field. Okay, their electric field is vector quantity, electric force is vector quantity. So those followed what a superposition principle. Here also magnetic field is vector quantity. On this magnetic field also what happened? Following that principle of superposition. I hope you understood what is the principle of superposition of magnetic field, right? So where B bar is what? Resultant magnetic field at a point, at this point. So what is a B1 bar, B2 bar and Bn bar? So B1 bar, B2 bar and so on Bn bar are what? Magnetic field of each individual source at that point. Students, I hope that you understood what is the principle of superposition of magnetic field. Simple, okay na? So B bar is equal to B1 bar plus B2 bar plus and so on plus Bn bar. Okay, principle of superposition of magnetic field states that the resultant magnetic field at a point due to magnetic field of several sources is equal to the vector sum of the magnetic fields of each individual source at that point. That is B bar is equal to B1 bar plus B2 bar plus and so on plus Bn bar, where B bar is equal to what? Resultant magnetic field at a point. So B1 bar, B2 bar and so on Bn bar are what? Magnetic field of each individual source at that point. Okay, dear students, next I'm going to discuss magnetic force. What is a magnetic force? Right? When a charge moves in a magnetic field, okay, it experiences a force. When a charge moves in a magnetic field, let us suppose current carrying wire, one charge produces a magnetic field. Okay, in that field, any another charged particle is moving nothing but, okay, on the charged particle, that charged particle what experience a force. That force is called as what? A magnetic force. Right? So on what factors this magnetic force depends? Okay, magnetic force depends upon following factors. Okay, what are they? First one, the force acting on the, so what is this here? Magnitude of force. The magnitude of force acting on the charged particle is directly proportional to the magnitude of the charge. Magnitude of the charge increases, then force acting on the magnitude of force acting on the charged particle also increases. Then second one, F is proportional to B, means magnetic force acting on the charged particle is directly proportional to the magnitude of, okay, magnetic field produced by the charged particle. Okay, what is second one? Magnitude of magnetic force acting on the charged particle is directly proportional to the magnitude of the magnetic field produced by the charged particle. Third one is, okay, F is proportional to V sin theta. F is proportional to V sin theta. F is what here? Magnetic force. Proportional to V sin theta is what? V sin theta is a velocity component. This V bar is a velocity of the charged particle. Velocity component which is, okay, perpendicular to the V bar. So V sin theta is more than magnitude of force acting on the charged particle also more. Okay, so combinedly write these three cases, three factors, then we'll get F is equal to QVB sin theta, where you will get the proportionality constant. That proportionality constant, okay, you take what? 1. Then you will get what? F is equal to what? QVB sin theta. Okay, so in vector notation, already in vectors, mathematics or physics in first year you understood vectors. Vectors, A bar cross B bar is equal to AB sin theta. A bar cross B bar is equal to what? AB sin theta. A bar cross B bar is equal to AB sin theta into n cap. Right? That is a cross product of two vectors. What is n cap? N cap is a direction of. N cap is a direction of A bar cross B bar. What is the n cap direction? It is which is perpendicular to the plane containing this A bar and B bar. Let us consider A bar is like B bar. A bar is instead of A bar, what is taken? What I have taken here? So velocity of the charged particle. So instead of B bar, I taken a magnetic field. Magnetic field is in this direction. Velocity is in this direction. Okay. Then so V bar cross B bar. Okay, or A bar cross B bar is nothing but AB sin theta into n cap. Then V bar cross B bar, I can write what? VB sin theta into n cap. The n cap is nothing but that n cap is perpendicular to what? V bar and B bar. Right? So then F bar, F is equal to QB sin theta. This is a magnitude of force acting on a charged particle. Okay, which is depends upon the magnitude of charge and depends upon the magnitude of velocity, it depends upon the, okay, velocity component, that is V sin theta, which is perpendicular to V, and depends upon the magnitude of magnetic field. Okay, that is written here. F bar is equal to Q into V bar cross B bar, okay, from vectors definition. Why it is V bar cross V bar? Why not it is B bar cross B bar? Why we are writing only V bar cross B bar here? Why not it is a B bar cross V bar? Nothing but, okay, so V bar cross B bar in that direction. V bar cross B bar direction means the force is, okay, maybe it is a upward or downward. Okay, so but in this magnetic force situation, okay, magnetic force case, the magnetic force is acting, okay, perpendicular and upward here in this case. Okay, so that is also taken some iron fillings, right? A current carrying wire, iron fillings. Okay, they poured some iron fillings. Then to easy understand,